Soil is the source of all terrestrial life, yet its delicate balance of minerals can be easily disrupted by wildfires that release toxic heavy metals into the local environment. Plants usually absorb and store heavy metals from the surrounding soil. However, when wildfires arrive and burn the plants and vegetation, the high combustion temperatures cause these heavy metals to be released back into the atmosphere and vaporized through heavy metal volatilization, remaining briefly in the atmosphere as aerosols and then recondensing to fall back onto the soil surface layer, as was evidenced by wildfires that occurred in southwest China and the subsequent soil samples that were taken. Another study found that wildfires can also increase the abundance of other simpler metals in the soil, especially aluminum, although iron and zinc can also vary depending on a lot of physical factors like topography, slope, wind direction, or the direction of wildfire spread. In addition, it can also be affected by the density of vegetation and what types of plants are present, such as having certain types of oak. Wildfire temperature or severity is also another important factor to consider, as for severe wildfires where the temperature reaches 500 degrees Celsius or greater, the initial heavy metal concentration in soil is actually initially lower because of ash being relatively alkaline due to the presence of oxides, hydroxides, and carbonates that causes it to be able to stick to organic matter. However, as the ash gradually dissolves over time, this association loses its strength, and the heavy metal concentration does increase towards the end. Nevertheless, though, because of that, medium strength wildfires do result in the maximum heavy metal concentrations available due to not having that initial alkaline ash that bonds to organic matter.
Furthermore, wildfires not only release heavy metals back into the soil and air, but also further toxicate the existing metals through heat exposure that causes chemical changes. For example, chromium, which is otherwise slow to convert to toxic levels, but when exposed to the heat and combustion of a fire, exhibits oxidation to become even more toxic in the form of chromium-5, and this product can then last in the ground for over a year, making it hard to remediate. The coupling of both more deposited metals from industrial runoff and increased frequency and the size of wildfires with climate change means that metal toxification is only going to continue to grow as an issue in the near future. Their subsequent deposition in both the soil and air has repercussions for humans through impaired agricultural yields and aerosol exposure, and animals through lower biodiversity. Collective action must be taken to mitigate and remediate this. Luckily, the analysis already done on heavy metals in soil provides a good tool for administering site-specific solutions, which is incredibly important for making risk-based judgments for communities like Palisades and Altadena in the aftermath of wildfires.